Welcome to this Maths Minis video on trigonometry basics. To start with, let's take a look at standard trigonometric values. So like we can see on the screen here, we have a table with key angles and corresponding values that you'll need to know moving forward. And we want to know these values in exact form so that we don't lose any level of accuracy when carrying our values forward. Okay, so take note of this table here. Now, if you're particularly eagle-eyed, you might notice that the values for 360 degrees are the same as the values at 0 degrees. And this is not a coincidence. The graphs for sin x and cos x repeat every 360 degrees. They're periodic about 360 degrees. And the tan x graph repeats every 180 degrees. And we can see that from the table here. So 0, 0, again, 0 degrees and 180 degrees. Okay, again, another 180 degrees there. You can see the same value for tan x. And in case you forgot how to derive these exact values, here's a useful way of remembering. So start by imagining an equilateral triangle with side length 2 centimeters, and split the triangle in half and label each side appropriately. So you get something that looks like this. Okay. So for the angle that you've forgotten, select the appropriate two sides to find that angle. So for example, let's say you've forgotten the value of tan 30 degrees. Well, remember tan x. So let's just write this here. Tan x is equal to the opposite over the adjacent. Okay. So in that case, if we choose tan 30 then, so for tan 30 here, tan 30 degrees, well this would simply be equal to 1, the opposite, over the adjacent, which is the square root of 3. Okay, so that's 1 over the square root of 3 there. Okay, and like you can see, it's rather straightforward. And you might have also noticed that tan of 90 degrees and tan of 270 degrees don't have any values. Well, think about the triangle above. If we're looking to use the opposite and adjacent sides, our opposite is typically the hypotenuse. So how then would we decide which adjacent side is the adjacent? Well, we can't. So that suggests that our system fails at these values. Okay. So that gives us everything we need there for standard trigonometric values. Moving on now to the unit circle. Now to recap here, the unit circle is a circle of radius 1 and it's centred on the origin. Now any point on the unit circle has coordinates cos theta, sin theta. Now this might sound all a bit confusing, so let's see what the unit circle would look like. And we can simply see it from here. Our circle has radius 1 here, 1, 1, 1 and 1, and it's centred on the origin. And like we can see here, any point on the unit circle has coordinates cos theta, sin theta. So any point can be expressed as cos theta, sin theta. Well, for example, let's say theta equals 30 degrees. So let theta equal 30 degrees. What would this give us? Well, in that case, we would obtain cos of 30 degrees and sine of 30 degrees. And we can simply find the exact values here for cos of 30 degrees and sine of 30 degrees. And this would simply give us root 3 over 2 and a half, 1 over 2 there. Okay, and that's our coordinates there. And these coordinates here give us exactly 1 unit away from the origin here. So this is exactly 1 unit away. 1 unit away from the origin. Okay, and it's worth noting here that obviously the degrees that we measure here go from 0 to 360. Again, we can keep extending past that, but at that point we just keep repeating the unit circle there. Moving on now to the trigonometry graphs. So let's start by denoting the graphs of y equals sin x, y equals cos x, and y equals tan x. So the first graph that we can see here on the screen is for y equals sin x. So this is for y equals sin x. Okay, and we note here that sine x has a maximum at 1. Okay, that's a maximum at 1 and a minimum at -1. Okay, if we go across here, you can also see that here as well. And we can note that sine x is periodic about 360 degrees. Okay, we go through 0 here, we go through at 360 here, we go back through at 720. Okay, so we can clearly see that it's periodic about 360 degrees. For the next graph then, what we have here, and as long as we match the pen colour here, what we've got is y equals cos x. Okay, so this is the graph of cosine of x. And again, just like sine x, we have a maximum at 1 and a minimum at -1. Okay, and again, just like sine x as well, cos x is periodic about 360 degrees. Okay, we have this maximum at 1 here. We can see we also have a maximum again at 360 degrees, 720 degrees, and -360 degrees. So like we just said there, it's periodic about 360 degrees. And then that just leaves us with our final graph here of y equals tan x. Okay, so y equals tan x. And for y equals tan x then, well, we don't have a maximum or a minimum. But what we can see for y equals tan x is that it's periodic about 180 degrees. Okay, it repeats every 180 degrees. Okay, you can see that here at -180, -360, and 360. Okay, and what we can note here is these green indicator lines are along all values of x where tan x has no value. And these are known as asymptotes, okay, which you might already be familiar with. Okay, and we can see that here with these green indicator lines. So that gives us everything we need there for trigonometric graphs. And to conclude our trigonometric basics here, we need to be able to confidently convert between degree and radians. Now, degrees is something we should be quite familiar with by this point. However, you may not have come across radians just yet. However, we can easily convert between degrees and radians using the fact that 360 degrees here is equal to 2 pi radians. So we write this as 360 degrees being equal to 2 pi radians. Now notice for degrees we use this little symbol here. However, for radians, there's a few ways you can express this. You can express this as 2 pi rad, like so. You can express this as 2 pi followed by a little r, or you can express this as 2 pi with a little c here to represent radians. All of these forms here are equivalent in representing radians. And you can easily use the fact that 360 degrees is equal to 2 pi to obtain any value in this table. For example, if we wanted 180 degrees, well, we'd divide 360 by 2, and we repeat that here with the radians. 2 pi divided by 2 simply gives us pi. And if we want 90 degrees now, well, we'd simply divide 180 by 2, and we'd divide pi by 2 as well. And again, if you wanted 45 degrees here, in radians, well, we'd just divide 90 by 2, so pi over 2 divided by 2 would simply give us pi over 4 there. So that's how we can easily convert between degrees and radians there. And that concludes this Maths Made Easy video on trigonometric basics.